Hi, this is Monica, and this is my answer to, or my solution for number 912, sort an array. Given an array of integers nums, sort the array in an ascending order and then return it. Use the smallest space complexity possible. Do not use the dot sort function, and sort in nlogn time complexity. So for this problem, I used quicksort to sort the array, and that has an average time complexity of n log n. So quicksort is also a recursive algorithm. So I call the helper function quicksort in 3 different places: 1, and then recursively 2 or 3. I also have 3 parameters. This nums never actually changes. As you can see, it's the whole array here, then the whole array here, then the whole array here. The arithmetic for the pointers is such that it'll sort within its contiguous chunk of that array. But I start off calling quicksort for the entire array, so the contiguous chunk is 0 to length of nums minus 1, so that'll be the entire array. And then it'll call quicksort for that, and it'll return the sorted array and return nums. Next, I use the Lamuto implementation of quicksort, where I choose the partition pivot to be the value at the rightmost part of my contiguous chunk. So there is an edge case where the values can be in such a way that you pick the worst possible pivot by choosing those rightmost values at each turn, which will lead to a runtime of n plus then you call it, and it's n minus 1 length, the n minus 1 length contiguous chunk, because then the pivot value is in the right place, but nothing else is. And plus n minus 2, same scenario, n minus 3, etc. That is a series that sums up to n times n minus 1 divided by 2, I believe, which is an n squared runtime. I had this issue with a failed test case, so then I created an optimization where it's actually a truly random value in the contiguous chunk. I do this by finding pivot index being a random value between the 2 bounds of the contiguous chunk. Then I switch that with the rightmost index. And so now it's a truly random value from the contiguous chunk being x, which is the partition value or pivot index. Next, I have another optimization to make this pass the test cases, where I use the Dutch national flag, basically 2 pointers to save where my chunks are. So I is my linear scanning index. It'll go from P to R, or P to the up to the edge of the greater than chunk, which it starts off being R, but it'll keep growing downwards. And that is already values that have been looked at. So it'll go from the first value to the edge of where the values have already been looked at. So while I is less than or equal to the greater than chunk, go through this code. So to go through this code, if the array at I is less than my pivot index value, then I want to switch it with the edge of the less than edge of where my lesser than values are. Then I increment both that edge and my I. Else, if it's greater than that, the greater than chunk grows downwards, so it'll be minus equal 1. And then again, I swap my current index and then that greater than index. And because I swapped, that means that my current value that I'm looking at may or may not actually be in the right section. So I don't actually increment I. Instead, I go through the loop again to sort that I. Else, if it's equal to x, the middle value, I'll just say, okay, fine, and then I'll just increment I. Right.